In this section, we're going to take a look at something called mutexes. So mutexes, you may have heard them before. Basically, they're going to be a way to ensure that some set of threads or some set of processes, there's maybe a resource available to them, and only one of them can use it at a given time. Now, in the previous section, we talked about kind of hardware mechanisms, right, for having some, well, being able to kind of manipulate numbers in an atomic way that was safe, right? Before we had that issue, right, at the way beginning of the section where we said, okay, hey, I have two threads running at the same time. I end up with values, right, that kind of go out of sync because it depends on what order things were implemented, right, and then kind of the hardware stuff we've just seen. Well, that stuff, right, basically we're saying is we're going to take these operations and we're going to make them atomic, right? We're going to make them kind of all happen together, and that gets rid of the original issue. Well, that hardware stuff is still a little bit hard to use, right? It's a little bit low level. So mutexes basically are going to be kind of our level of abstraction built over that, right, as a way to uniquely gain access to something, right? Prevent different threads, right, from entering the critical region, from doing something right at the same time, or using a resource, at the same time that they really shouldn't. I'll talk more about the critical section problem in a second. Basically, what I say is this: a mutex basically you can imagine as being a variable in your program, and we'll call it a lock, right? And basically, only one thread in your program is allowed to open that lock or use that lock at any given time, right? So there'll be two kind of commands associated with a mutex lock. One is an acquire, right? So you go to your lock, your mutex lock, and you go, okay, I want to acquire this lock. Well, two things can happen. One, nobody else is using that lock, is using the, and there's, I'm saying the word lock here, right? But really behind the scenes, there's some sort of like resource or something like that, right? But here, right, you go up to your lock, right, and you try to acquire it, and maybe, it's available. Well, in that case, you're good to go, right? You acquire that lock, right, and then in your program you can picture, oh, now I can do some other stuff, and a lock somehow implies that this one resource is available to me, right? Now then there's the other case, right? The other case is you go and you try to acquire a lock, and if you do that, all of a sudden, hey, somebody already is using this lock. Well, in that case, right, your program will wait around, right? So it won't be able to proceed, because in order for that program to proceed, what your lock is doing, right, or your mutex is doing is saying, okay, I need to wait for this thing to become available to me specifically, and then I can do this other stuff, right? So if somebody has acquired that, right, I'm going to wait there, eventually they'll be done, right? They'll release that lock, and then I'll be able to acquire and go in and execute the code that I want to do, right? So I'm kind of, my mutex locks, right? Any number of people can go and try to acquire them, but only one at a time is going to be kind of let through that gate, right? It's going to be able to acquire that lock and proceed downwards, right, to execute code. Everybody else is going to have to wait for that lock to actually become available. So let's say you acquired it, right? You do your stuff. Well, at the end, what you need to do, right, is you need to release that lock, right? Now you're done, maybe using that resource behind the scenes, right? And so now you can let somebody else go ahead and do whatever they want. So then basically the rest of your system can actually make progress, right? Remember we said that, hey, if I have a bunch of things that are waiting around, right, in that bounded, the kind of the bounded time requirement, right? I want to make sure that things all have their chance to go, right? We're making progress. Nobody gets stuck behind the scenes, right? So I'm doing my release to make sure that other people can use that resource. So you can maybe think to yourself for a second, how could we really use this to solve the critical section problem is one thought. Well, here you can imagine the following. Basically, is you would have one lock, right? Global lock that basically says in critical section, right? One lock out there, right? And then my different threads, right, in my set of threads, whenever they want to execute that critical section, they would try to acquire that one lock, right? So it's basically this one global thing, right, that everybody's trying to compete for, right? Then a thread, gets that lock, does critical section, then releases it, right? So as long as we have something like that, we're actually able to solve the critical section problem pretty easy, right? We just have this one global lock that says only one person is allowed to lock this, and once they lock it, then they can go to their critical section. So as kind of an additional final note here, when we think about what happens to a thread when it's trying to acquire something that's not available, there's a couple things that can happen. One thing that we've kind of seen in like the previous section is just having a while loop, right? So we have a while, then a condition, then a semicolon after, and basically when we do that, well, it's bad, okay? Hopefully when you see a while loop, right, that's basically an infinite loop with a semicolon, there's no work inside of it happening, it seems wrong to you, right? That's what we call busy waiting, right? So it's just going to spin there indefinitely. We technically could do that, right, for operations that need to wait for something, but a better approach would be to say, okay, I'm going to basically change the state of the thread, right? So the thread, instead of being, running, right, maybe I change it to wait, right? Or I put it to sleep, right? Or I move it to a different type of queue or something like that, right? I don't want it to be waiting there. So there's a couple ways we can implement stuff. Hopefully we don't use busy waiting though, because that is just going to slow us down.